Welcome to the Q&A session 16 from the playlist of electrostatic potential and capacitance. The topic is the sharing of charges, and based on this topic I have selected one question for this session, this question is available in NCERT exemplar. So the question here is: two metal spheres of radius r and 2r have same charge density sigma. They are brought in contact and separated. Then find the new charge densities on them. That is, we have to find the charge densities on both the spheres after they are brought in contact with each other and separated. So we know that the surface charge density is equal to Q divided by A, where Q is the total charge residing on the surface of the sphere in this case, divided by the surface area. So the surface area of the sphere is equal to 4 pi r square. So if the total charge residing on the sphere of radius r is Q1, then sigma will be equal to Q1 divided by 4 pi r square, where r is the radius of the sphere. So from this equation, I'm getting Q1 is equal to sigma into 4 pi r square. Similarly, if the total charge residing on the surface of the sphere of radius 2r is Q2, then sigma will be equal to Q2 divided by 4 pi 2r whole square. So this is equal to Q2 divided by 4 pi r square. So 4 pi r square into 4. Or this can be written as Q2 divided by, this can be written as Q2 is equal to sigma into 4 pi r square into 4, and sigma into 4 pi r square is equal to Q1. So Q2 is equal to Q1. That is, the total charge residing on the surface of the sphere of radius 2r is 4 times the total charge residing on the surface of the sphere of radius r. So another relation which I have got is that Q2 is equal to 4 times of Q1. Now, as per the law of conservation of charge, the total charge before the contact will be equal to the total charge after the contact. Now the total charge before the contact is equal to Q1 plus Q2. And let us say after the contact and when the spheres are separated, then the charge on the sphere of radius r is, say, Q1 dash, and the charge on the sphere of radius 2r is say Q2 dash. So since the total charge before the contact and after the contact will remain the same, therefore Q1 plus Q2 will be equal to Q1 dash plus Q2 dash, and this will be equal to, here Q2 is equal to 4 times of Q1. Q2 is equal to 4 times of Q1. So Q1 plus Q2 will be equal to 5 Q1. Or we can say that this will be equal to, Q1 is equal to sigma into 4 pi r square. So this is the another equation which I have got. Now when both these two spheres are brought in contact with each other and then separated, then the potential of both the two spheres will become equal. So in that case, I will get another equation, that is 1 by 4 pi epsilon naught into Q1 dash upon r. This will be equal to 1 by 4 pi epsilon naught into Q2 dash upon 2r. So from here, I will get another relation, that is Q1 dash is equal to Q2 dash by 2. Q1 dash is equal to Q2 dash by 2, or we can simply say that Q2 dash is equal to 2 times of Q1 dash. So this is another relation which I have got by equating the potential of both these two spheres after they are brought in contact with each other and separated, and when they are brought in contact with each other and separated, then the potential on both the two spheres will be the same. So by equating the potential of both the two spheres after they are brought in contact with each other and separated, we got another relation, that is Q2 dash is equal to 2 times of Q1 dash. So now here Q1 dash plus Q2 dash is equal to 5 times of Q1. So here what I will be doing is I will be substituting the value of Q2 dash as 2 times of Q1 dash. So I will be getting another relation, that is Q1 dash plus 2 times of Q2 dash. This is equal to 5 Q1. So this is 3 Q1 dash is equal to 5 times of Q1. Now Q1 is equal to sigma into 4 pi r square. So Q1 dash is equal to 5 upon that is equal to 5 into 4 is 20 into sigma into pi r square divided by 3. So I will just write the value of Q1 dash is equal to 20 into sigma into pi r square upon 3. So the new surface charge density of the sphere of radius r after both these two spheres are brought in contact with each other and separated, say it is sigma 1. This will be equal to the total charge residing on the surface of the sphere divided by the surface area. So this will be equal to 20 into sigma into pi r square divided by 3 divided by the surface area of this sphere, which is equal to 4 pi r square. So here this pi r square and pi r square will get cancelled out, and the new surface charge density of the sphere of radius r after both these two spheres are brought in contact with each other and separated will be equal to 5 by 3 sigma. So here I am writing sigma 1 is equal to 5 by 3 sigma. Now we have to find the new surface charge density on the sphere of radius 2r after both the two spheres are brought in contact with each other and separated. So here we see there is one equation, that is Q2 dash is equal to 2 times of Q1 dash, and Q1 is equal to 20 into sigma into pi r square. So 20 into 2 will be equal to 40 into sigma into pi r square divided by 3. So this is the total charge residing on the surface of the sphere of radius 2r after both these two spheres are brought in contact with each other and separated. So sigma 2 is the surface charge density of the sphere of radius 2r after both these two spheres are brought in contact with each other and separated, and this is equal to 40, that is Q2 dash, divided by the surface area. So here the surface area will be equal to 4 pi, here the radius is 2r, so this is equal to 2r whole square. So from here this I will be getting 40 into sigma into pi r square divided by 3 into 4 pi into r square into 4. So from here this r square and r square will get cancelled out, pi and pi will also get cancelled out. This 4 into 10 is equal to 40 to 5. So finally the answer is 5 by 6. 5 by 6 sigma. So sigma 2 is equal to 5 by 6 sigma. So the new surface charge density on the sphere of radius 2r after both these two spheres are brought in contact with each other and separated is equal to 5 by 6 sigma, and the new surface charge density on the sphere of radius r when both these two spheres were brought in contact and separated is equal to 5 by 3 sigma. So in this question what we have done is we have utilized the two concepts. One was the law conservation of charge, and according to it the total charge before the contact and after the contact will remain the same, and the second thing is that when the two spheres were brought in contact with each other, then their potential will become the same. So by equating the potential of both the spheres after they are brought in contact with each other, we got another relation, that is q2 dash was equal to 2 times the q1 dash, where q2 is the charge on the sphere of radius 2r after both the spheres were brought in contact with each other and separated, and q1 is the total charge on the sphere of radius r after both the spheres were brought in contact with each other and separated. So thank you very much for joining this session. In the next session I will be coming up with a different topic from the same chapter, that is electrostatic potential and capacitance. So till then, have a nice day. Bye.